Hello, this is Keenan Maxfield. I'm an instructor with Solar Energy International, and I'm going to talk a little bit about temperature with our solar systems, with the solar panels. Now, if you're needing information about how to do the math and the formulas, equations, and stuff like that, unfortunately, that's outside the scope of this video. We're talking more about which temperatures to use for that math and where to get that information. So, of course, when the temperature gets colder, the voltage goes up. So you want to use a design minimum temperature, and then also as the temperature goes up, the voltage goes down. So you need a design maximum temperature. What temperature do we use? Where do we get that data? So if you're a student in our 202 class, which is where we teach it, you'll see this assignment, and we have these links. And I always used to tell people to use this Solar ABC's interactive map. But unfortunately, if you click on that, this map has been discontinued. And this was just a really easy way to get the temperatures. So we've got a few other options. We've got this expedited permit process, the ASHRAE table. If you click that link, it brings you to their website and you can download the full report. That's this one right here. And this is so if you're not in the class, I will put this link down in the description of this video. It's solarabcs.org. You can just Google search also Solar ABCs expedited permit process report. Anyways, you click on full report and you get this massive document. And here I always just use Control F for find, or Command F for Mac. And you can go ahead and type in any number of locations. We could put in Franklin, Pennsylvania. Now, so I happened to know that that was a city that was on this document. So if I happen to type in a city that's here, then boom, it shows right up. But however, if I were to type in a city that's not here, then obviously that's not going to work. So like if I were to put in Fairview, Utah, there's no Fairview. So in order to use this, you really have to have a little bit more familiarity with your home region. So instead of typing in Fairview, I could type in Provo, and Provo, Utah is going to come right up. Now I happen to know that that is actually a long ways away from Fairview, but at least that gets me Utah, and I can see all the data sites in Utah. So I can use my regional knowledge of Utah to try to pick the closest one. Now, once you have a spot on this map, the numbers we're interested in is the high temperature, and we can use the 2% average. And what that means is that on an average year, no more than 2% of the hours in that year will it go above this temperature. So that gives a pretty nice temperature for that. And we can remember if for 2% of the hours of the year, the temperature does go above that, then we're only losing a tiny bit of energy, because the voltage is going down as the temperature goes up. And if the solar voltage goes down, then all that happens is that we lose production. It doesn't actually harm any equipment. However, we're going to use a more extreme number for our cold temperature. This is the extreme minimum. And this is the absolute coldest temperature that you will ever experience in a mean year. And that basically is like an average year. So it's still not the record low, but it is much colder than a 2% average would be. So if you want to use this resource, this is a great one. However, it's still a bit challenging to use, especially if you're not really familiar with all the names of all the cities in your state. So we're going to check out a different one. And here we go. We're going to go to ashrae-meteo.info. And I will put this link in the description, but you can see how it's spelled right here. We're going to go to this website. And this is an interactive map. And this is pretty cool. You'll see in a minute what the disadvantages of this are. But I'm going to go into North Pole, Alaska here to show how I would use this one. You're going to just navigate the map to your desired location. North Pole specifically because that's where I'm moving, so I have interest in this area. I'm going to right click on the map. When the moment I do that, it gives me this grid. I can see all these different data sites. I can see them visually. So I can start picking the closest ones to my area. Now, again, if you do have some local knowledge, then that is helpful. For example, I would not choose this site because that's up on the mountains. And I would expect up on the mountains to be a different uh, climate than down here in the valley. So, yeah, some amount of knowledge of the area is still really helpful. But, I'm going to click on this data site and then I might click on this data site up here to compare them. Now, the problem with this website, it's an advantage and a problem at the same time, is that it gives you lots and lots and lots of data. So that's why we haven't really steered students towards this website in the past very much. But really, we're only interested in two numbers from all of this data. And again, we're going to try to look at our cooling information to get our maximum heat. So we're going to go into this area and we're going to look for dry bulb, that's dB, dry bulb temperature, and we're going to look for 2%. And so then that gives us our 2% dry bulb temperature, of course, in Celsius. And that would be the number you would use. If you want to use a more conservative number, you can use one of these lower percentages. Like here, for 1% of the year, might get above that temperature. For here, for 0.4% of the year, it gets above that temperature. Of course, you can even go down to the hottest month and go monthly design and find your 2%, 4% for the hottest month. But that's excessive in most people's opinions. And the stance of the solar school is to follow the code, and the code thinks that that's excessive. Um, also, so yeah, that's our hot temperature. Now we're going to look at our cold temperature. We're going to find the word extreme annual design conditions. And we're going to look here at the extreme annual temperature, looking at the mean column. That's essentially like an average. We're going to say, okay, our extreme mean minimum temperature, dry bulb, is negative 43.1. So that would be the number I would use for designing the coldest temperature. Now, again, if you want a more conservative number, you can do that. You can say, well, what's the coldest temperature in an average 5 years? Or what's the coldest temperature in 10 years? And again, these are using probabilities. So it's kind of like the 100-year storm. You can get 300-year storms in a row. But using the probabilities, this is the coldest temperature you would expect to see in 50 years right here. So you can always use a more conservative number in the real world. If you are doing the assignment as a student, then we expect you to use the numbers that the school recommends. And so in that case, your number here is the 43.1. That's your extreme mean minimum. And again, for hot, you go to the cooling table, your 2% dry bulb is going to be right there. So pretty easy to use once you get your head around this massive chart. And that's all I have to show you. Thank you very much and have a great day.